Okay, this is problem number 12 on chapter 7, section 1. This problem is about sample size determination. We use these two formulas for this section. We don't use this one in this section right here. That is for section 7.2. So on 7.1 we are using either this formula or this formula, depending if you don't know anything about the percentage to be estimated. We use this part, like in part A. Assume that nothing is known about the percentage to be estimated. And part B, we use it, this part B, we use this formula when we know something about p hat. Okay, that's p hat. And so that's the difference between this formula here and this formula here. Well, let's start by getting the critical value. The critical value comes from the confidence level. Remember that we need to obtain that value of alpha, which is 1 minus the confidence level, which is right here. Okay, so we have a 90% as a confidence level. That 90% stands right here in the middle, so that is 0.90. And of course, on this side of the tail right here, we will have 5%, and on this other side we will have 5%, okay, of area. So these 5 plus 90% plus 5%, they add up to 100%. Okay, mathematically here we can find alpha. I mean that area right here, that's 5 and 5, which is 10. By using this little formula, alpha is 1 minus 0.90, which is 0.10. But remember that this value of 0.10 is divided by 2, because you have half of this area on the right and half of this area on the left. So alpha by 2 is 0.05. So to find the critical value right here, that little subscript represents alpha by 2, that little subscript right here, alpha by 2, and you want the score, the z-score, that has an area of 0.05 on the right of that score. To find that value, we use the calculator, and we press second bars. Remember, when we have area and we want the z-score, we use inverse norm. With area, the area right here is on the right side of that z-score. So when the area is given on the right side, right here, you need to write 1 minus that area, which is 0.05. That area 1 minus 0.05 represents the area on the left. And then we'll keep this 0 and 1 as the mean and the standard deviation. Press enter, enter again, and that is the critical value. So if I follow that formula right here, it says you need to raise that critical value to the second power. We can only just press x squared. By doing this, I'm going to raise this value to the second power, then multiply by 0.25. Let me see, 0.25, and divide all this by the margin of error, which is in this case right here. Divide this by the margin of error to the second power. Okay, the margin of error to the second power. So we press enter, and we always round up. Okay, we always go to the next whole number. There is a tolerance for this answer. Okay, you see all these are possible correct answers for this specific problem. You might get a different value than this if you only take like 3 decimal places on this critical value. So we have some tolerance for this answer. Part B is very similar process. So we have the critical value, which is right here, is 1.645. You round it up to the third decimal place. Okay, we have the p hat, which is 0.45, and q hat, which is the complement of p hat, is 1 minus 0.45, which is 0.55. Okay, so that's my p hat, q hat, critical value, and I have the margin of error. Again, if you want to get this number again, you can repeat the process: second, vars, inverse norm, or you can just go up, 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 press enter, raise this to the second power, just like the formula says right here, open a set of parentheses and multiply p and q. So that's 0.45 times 0.55, and then divide this by the margin of error, 0.02 raised to the second power, and that's how you get this 1675. Don't forget to round up. Round up means go up to the next integer, which in this case is 16.75. Okay, and that's how you do this problem.